So instead of just showing you do this, do this, do this, let's talk here. Wherever Z prime is going to end up being, what do we always know about our line of reflection? It's a perpendicular bisector for that segment that's going to be created, Z prime. So here's what I need. I need a perpendicular line coming from Z, right? I need to take care of this part right here, the perpendicular part. These two better be perpendicular to each other, and it's got to go through Z. You know how to do that already. Put your compass on Z, please. I just got to refresh your memory. Put your compass on Z and start playing around with your compass right now because you need to intersect line M in, anybody remember? 2 places. Good. This is going to look like a little smile here. Make sure it intersects in 2 spots. A reminder that if you cannot intersect in 2 spots, maybe it's only possible in 1. A reminder that lines go on forever, right? Lines go on forever. So you can always extend your lines if you need to make it intersect in a second spot. All right, everyone's got the 2 points of intersection. All right, now from here, you can keep your compass opening the same. You can open it wider, but the next 2 arcs need to be from the same opening of your compass. All right, everyone, the next 2 arcs have to be from the same opening. So you go put your compass point on 1 point of intersection. And again, make an arc. Again, don't make these huge ones here. That's where we start running into trouble when our arcs start to become huge. Again, when you make that arc here and you go to your second point, make sure your opening of your compass is the same. All right, go to the other point of intersection. Make these final 2 arcs intersect each other. And when we do that, you can grab your straight edge. And we're not done yet. We're only halfway done. Just draw in your perpendicular line. It can be a segment, a line. It doesn't matter. Make sure it's perpendicular to M. That is what matters. All right, so now take a look on my copy up here. I know Z prime's got to be somewhere on this line, on this side. It's not going to be over here on this side. It's got to be on the opposite side of M. Z prime's got to be somewhere on this perpendicular line. Where? Here comes the second part. Line M is a perpendicular bisector. So the distance from Z to M has to be the same from M to Z prime. Take your compass, measure that distance from Z to M. Measure that distance right here where that line crosses M. Measure that distance, because that's got to be the same distance on the other side of line out. So now I measure that distance. I take my compass. I move it over now to make sure now the compass point is on the intersection. And this is just pure coincidence. It doesn't happen like this all the time. That's where it ends up right here, Z prime. It's got to keep in your mind, it's got to be a perpendicular bisector. So the 2 lines need to be perpendicular and, right, the distance needs to remain the same from the point to the line and the line to the image. Questions from you guys? Going. 1 doesn't make us great. We did a point. Can we do a full figure now? So I want to take triangle JKH and reflect it over line M. Well, good news. I don't have to do all 3 points. Why not? What's going to stay the same? Okay, if it's on the line of reflection, it's not going to move anywhere. So we're already done with 1 point. This point's going to be K prime. I'll do one of the points with you, and then I'll let you do the last point on your own. Anybody have a preference? Actually, I'm not. Why do I ask? We're going to do J. All right, I'll reflect J with you, and then you do H on your own. So I need a perpendicular line going through M and J. Compass on J. That'll do it, yeah. Doesn't have to be anything huge as long as it goes through 2 spots. And again, for the last 2 arcs, you can keep your compass opening the same. In this case, I'm going to open mine a little wider just so I have more room to work. And the other reason why I don't like you guys having these huge arcs is because, remember, you still got another point to reflect. All right, you want 5 or 6 arcs all intersecting, and you're going to get confused. Try to make them small. We're good. Drawing your perpendicular line from J. And now match it. And we should have J prime there. And then I'm going to walk around right now and help anybody that needs help with H.
Why can't we just extend the line and then...
What's that?
Why can't we just extend the line and measure the distance to... I mean, so,
Extend the line?
yeah, like this, then just measure the
What
distance.
do you mean by extend the line?
Like, use a straight edge to... like, continue the line out, and then...
Okay, how do you know that line's going to be perpendicular to M? Because remember, it's got to be a perpendicular bisector. How are you guaranteeing me that that line is perpendicular to M? Right? It's not enough, Connor, that the distances match. It's got to be perpendicular distance. Okay? Lines can be extended, remember? If you can only hit line L in one spot, extend it further. compass. Compass. Ruler is just always for a straight edge purpose. Yep, ruler's never to measure. Okay, I'm going to let you have a minute here to finish up. If there's any issues, let me know here. This is going to be the last reflection we do together. The next one you guys will do is for homework. Okay, anything? We're good? Last thing, we know how to reflect. Can you find the line that we reflected over? And this is a heck of a lot easier than reflecting. As long as we remember, line of reflection is the same as the perpendicular bisector of a pre-image and its image. So that's your first job right now, is please take your straight edge and connect a pre-image with its image. It does not matter. All right, so we're making segment A prime, B prime, C prime, or D prime. It is your call. Your call. And now you got to remember, this is our big construction. This is the one we seem to use all the time. Do the perpendicular bisector of C prime. A little reminder how. Put your compass on one point, open up your compass. More than half the length of your segment. This is where we want to make about a half circle arc, about as big as they come. And then you keep your compass opening the same, and then we fly over here to C prime, or whatever image you have. Make sure you have not one, but 2 points of intersection. And then we grab our straight edge and do our perpendicular bisector, now known as line of reflection.
Do you have to do it for every single one?
Unless you want to check. I don't need it. All right, if you want to do another set of points, go ahead. If you want to make sure, just to be on the safe side, and check, but I'm only going to require one. All right. Any questions from you guys there? Going? So we now have taken care of reflections and finding the line of reflection. Last thing I need to show you is how do we do a translation now? Okay, how do we do a translation? And this is I'm going to slow it down here because this is a totally new construction here. First, let's understand what's being asked. All right, what is being asked? Everyone sees my notation, right? The capital T tells me translation. How? Ooh, I'm not giving you this anymore because we're not on a graph. What I'm giving you is, anybody remember what PQ was called up there? We drew one on a graph on our translation day. Kara? Array, we called it a what? Began with a V and an ector. Vector, yes. This vector, PQ, remember what it's telling you. Let me refresh your memory. It's telling you how far we need to move Z and in what direction. All right, so we need to move Z in this direction, this distance, and it's got to end up somewhere. All right, somewhere. So is everyone clear on what our task is here? Take point Z, move it this direction, this distance. Ready to go. First step, take your compass, measure the length of vector PQ. Measure, because I got to go that distance, right? However long PQ is how long I got to go. So everyone measure. Oh, come on, one job. There we go. There we go. Point to end point. Everyone's got it measured. Again, taking this slow. Go to point Z. Put your compass on the end point of Z. And we are going to, coming from Z, we're going to make our own arc there. Any point on this arc is going to be the length of PQ. We just got to figure out where on this arc Z prime is going to be. Because we are guaranteed by our compass, this distance from P to Q is the same from Z to any point we put on this arc. We just got to figure out the correct direction now. All right, so does everyone agree? At any point, don't do this on yours, any point on here is the same distance P to Q is to Z to any of these points. We just got to figure out the direction now. And here's how we figure out the direction. Ooh, sorry. Take your compass. Measure the distance from P to Z. From P to Z. Everyone have it? Now put your compass point on the tip of the vector. And we're about to find out where Z prime is, wherever it intersects that first arc. So again, we measured P to Z. Now we put our compass point on Q, the end of the vector, and make it intersect the first arc. And this is where Z prime is located. Please don't go on to the next translation. All I gave you there was a set of steps. Do this, do this, do this. But we're in what class here? One more time, what class are we in here? So why the heck does that work? All right, I just don't want to give you steps and say do it. I want you guys to understand why it works. Here's why it works. And I'm going to relate it back to an old unit. What was the first thing I told you to do? Measure PQ. So does everyone agree PQ and Z to Z prime are both congruent to each other? Everyone agrees. All right. Next thing we did. What did I have you measure? P to Z. I had you measure P to Z, and then you put your compass point on Q. So does everyone agree? P to Z, same distance as Q to Z. Can we all agree on that part? Yes. Hey kids, what figure did I just make up here? Parallelogram. Not only are opposite sides congruent, but they're also, so that guarantees me because they're parallel, we're going in the same direction. All right, so we're basically making a parallelogram when we translate. Okay, we're making the opposite sides congruent. All right, that's why Z prime will land in that spot. Questions here? Same thing I did for reflections. I will move 1 point with you. You move the other 2 points. Let's see. Let's move L together. All right, let's move L together, and then you guys can work on P to A. First step, measure your vector, please. Measure the vector. You're going to move it. Measure your vector. And again, I'm translating L. So I put my compass point on L. And make an arc. We are guaranteed that L prime will be somewhere on that arc. All right, L prime somewhere on that arc. Next step, measure L to N, the start of the vector to the point you are translating. Because think about it. We're doing one side of the parallelogram now. Now we're about to go to the opposite side of the parallelogram. Now I slide down and put my compass point on the end of the vector, so point E. And now I'm going to figure out where L prime is going to be. And keep in mind, you should be going the same distance and direction your vector is pointing to. Okay, same distance and direction your vector is pointing to. It should not end up on the opposite side of the vector. All right, it should always end up on the same side there as your point. All right, go ahead, I'll walk around, see your beautiful work. Reflecting and translating today. As you're working on that, on Friday, if anybody accidentally snagged calculator number 20, I would appreciate it back. No questions asked.
Oh, shoot.
No, thank you. No problem. Definitely not the first or last. You all right, boss? What's going on? The compass? What'd you just do? So the distance, and then you did it from L?
Yeah.
Okay, now you measure the distance from the start of from the point you're translating to the start of the vector. Measure the distance from L to N now. The start of the vector from the point you're translating. Now you put your compass point on the end of the vector. Yep, and now make them intersect because you're going that direction. Measure L prime. I think many of you are starting to notice, hey, making small arcs is the way to go so they don't all run into each other.
Wait, Mr. Barney.
That triangle should not be bigger, right? Because translations don't change the size. I'm gonna say probably A, because look, it's gotta go this way, right?
Yeah.
A is kind of going, that if I draw that vector in from A to A prime, it's not gonna go in the same direction as that. So get your compass again, measure EN again, measure the vector. We'll start from step one, measure the vector. Okay, go from A, make that arc. Okay, here we go. Now you go from A to the start of the vector. So A to N in this case. Yep. And then you put your compass point on the end of the vector and make it intersect that. Yeah, we're off there, right? That's where A prime should be.
Well, I messed up.
Let's go, grab your compass.
Measure E.
Yep. And now what point are we? Right up, put your compass on L. Make an arc. Now. Okay, now I measure from L to the start of the vector. And now go to the end of the vector, put your compass point on the end of the vector. E, yep. And now make them intersect with that first arc you just had. There you go, that's where L prime is going to be.
There's a one. I have a feeling our days are wrong.
Okay, well, let's do it again. Yeah, maybe a little, we'll see. Okay, so measure your vector. Okay, go from A, right, we need to make an arc from A. Okay, we'll now measure your distance from A to the start of the vector, right? So now go to the end of the vector. And it's your, whatever intersects.
Like that was way less than.
It probably would help to have a
Theo, are you okay?
reliable
Yeah, let's.
compass too.
Fine.
Okay, because that'll happen when you have to hold the opening versus just letting it go.
Yeah, I just couldn't find it. It's in my bag, but it's a lot less flimsy.
You guys should certainly move on. I like that technique. I would put out. I like that technique. Starting out with the distances first.
So you obviously.